Okay, part 4 of our fancy counting series. We'll call this Choosing But Make It Weird, and our guest lecturer, Cleo, is here to help us. She's not really helping, but she's very cute. Okay, so here's the new dilemma. So choosing but make it weird. In the last video, we talked about choosing, how like if I have 5 snacks and I choose 2, the number of ways to do that is like 5 factorial divided by 2 factorial times 3 factorial, all in the denominator. So here's the new scenario. Our juniors, so you guys, our current juniors, need to pick exec members. Need to pick an exec council. Okay. If there's about 350 of you, how many possibilities are there for exec for next year is the question. So the first thing we need to do is we need to choose a president. So when we choose a president, there are 350 possibilities, right? So hypothetically, 350 possibilities for a president. After we've picked the president, now we want to pick the VP. So after we pick the president, there are 349 people left that could be VP. Okay, you kind of see where we're going with this. How many people left to be secretary would be 348. And how many people left to be treasurer would be 347. Okay, so, and once we've done that, well, that's just it. We've picked our entire exec. So the answer is just going to be, like, the number of ways to pick it is just 350 times 349 times 348 times 347. Full stop, right? That's the number of ways to pick exec. Which is a huge number, by the way. Like, that is insane. Like, it's close to 350 to the 4th power, which is crazy. But I wanted to talk about it one more way, okay? And it has to do with, like, choosing, but it's a little bit weirder, right? Because we could choose 4 people to be an exec, but now the order kind of matters, right? In our last example, we were just putting snacks into our lunch bag. It didn't matter what order we put them in the lunch bag, they just ended up in the lunch bag. But now we actually have this like ordering of like there's a president, VP, secretary, and treasurer. So just picking 4 people isn't good enough, right? So there are a couple different ways you can think about this, okay? We're going to think about it kind of from the same perspective that we talked about choosing last time. So one way that we could choose exec is we could take all of the juniors in the whole school and line them all up, right? And talk about every possible way to line all the juniors up. Every possible way to line 350 juniors up is 350 factorial, which is a huge, huge number. Okay, but that's the number of ways to line all the juniors up. And then we could say, okay, just the first 4 people in line are going to be exec, right? The first 4 people in line are going to be exec. But now, in our previous one, we said the first 2 things went in our lunchbox, and we don't care what order, so we'll divide out. But now, we actually want the order to count, because we're going to say the first person in line is president, the second person is VP, the third person is secretary, and the 4th person is treasurer. So we don't want to divide out by it, because we want to keep that order of the first 4 people. But after those 4 people, the rest of the 346 people left, we don't care what order they are in, right? Because they're not in exec, so it doesn't matter. So we want to divide out by their order. So we have to divide by 346 factorial, right? For the people that didn't get chosen, we don't care what order they're in the order. But if we write this out, like if we look at the expanded form of these factorials, so this is 350 times 349 times 348 times 347 times 346 times 345, all the way down to times 2 times 1. I'm not going to write all those out for you. Over 346 times 345 times 344 times blah, 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 all the way down to 2 times 1. Look what happens when we start finding those fancy ones, right? 346 and 346 are right here, right? So starting at 346, this 346 factorial kind of cancels out the 350 factorial. So we get the 345, the next one would be 344, and it's going to happen all the way down to times 2 times 1, where we get these fancy ones. And we're just left with 350 times 349 times 348 times 347, right? Which is what we said in the first way. So this is just another way to think about it, is 350 factorial divided by 346 factorial. So unorder all the people that don't get put in exec. Okay? So this is a scenario in which we choose, but we want our choice to stay ordered. let me see. Oh, okay. Cool. So we've got this. This is the number of ways that we could pick these 4 exec members out of 350 juniors. But we forgot something. We forgot our members, which, if I remember correctly, we have 4 members in our exec team. But if I didn't, just pretend with me. So we forgot our 4 members. Okay, so now that we've already picked our leading 4 exec members, president, VP, secretary, and treasurer, now we're going to pick our 4 members. So how many ways are there now to pick the 4 members once we've already picked them? Well, there's 346 juniors still remaining. So we have 346. Okay, and we just want to choose 4 of them. Once they're members, members aren't distinguishable, if you say that right. They're just members. So we just need 4 people. So we're just going to calculate 346, choose 4. Because these things are indistinguishable. We just need 4 members. They're not ordered like the president, VP, sec, treasurer. We're just we're just choosing them. So this, remember our n choose k formula, this is going to be 346 factorial over the number of ways to order the members we picked, so 4 factorial. And then we also divide out by the number of ways to order the people that didn't get chosen. So 346 minus 4 is 342, so we have to divide it by 342 factorial. And if we expand these out, the 342 factorial is going to start canceling the 346 factorial at 342. So we're just going to be left with 346 times 345 times 344 times 343, whoops, over, that's gone, and just the 4 factorial. So 4 times 3 times 2 times 1.